Ferroelectric Actuation. Qualified in the London lab. Ananya Barakrishna, University of Oxford.
7 million lives were lost in 2012 and several others were affected by air pollution. A primary cause to this is the industrial and vehicular emission. Fuel is injected into your engines, it's compressed and burnt. But the truth is, not all the fuel which enters your engine is completely burnt. In fact, a significant amount is emitted as nitrous oxide, hydrocarbons, and other toxic wastes. One way to reduce these emissions would be to inject just the right amount of fuel into your engines. This would mean you need someone to tell you how much fuel is needed, that's a sensor, and more importantly, we need a mechanism which can mechanically inject or displace just the right amount of fuel to your engine. That's called an actuator. Any mechanical device which has the capability to produce such displacements are called actuators. For instance, look at Calvin. When he senses a lizard, he's going to jump up. He's creating displacement, and it's an example of actuation too. Engines today have highly advanced sensing units. They can precisely tell you the right amount of fuel that is required. But what engines do not have is an effective actuator which can generate large displacements. This is the wall which needs to be broken. What I'm looking at are materials called ferroelectrics. These are called as smart. And what really makes them special and unique is you take a crystal of ferroelectric and you expose it to electric field, it can change its shape. It means it can generate displacements. So if I take a strip of this material, stretch it, mechanically clamp it, and now apply electric field to it, or I take a slender beam of the material, fix its edges, and now apply an electric field, I'm forcing the material to deform. And by causing this deformation, I'm making these materials actuate and behave as actuators. And what is important in here is that these ferroelectric actuators can generate displacements which are several times larger than what the piezoelectric actuators in market can currently offer. And more importantly, they need very small driving voltage to run them. If this novel concept is industrially realized and employed everywhere, they can minimize vehicular emissions and make the world a better place to live in. This, ladies and gentlemen, is breaking the wall of ferroelectric actuation. It's going to make this place a better place and definitely going to save a lot of your money you spend in the fuel as well. Thank you.
How much more fuel efficient would the vehicle be with this kind of mechanism?
So nearly 30% of the fuel that is injected into the engine is unburned. So by using a precise mechanism where actuation takes place, where you can have an efficient, effective actuator, you can minimize it. So that would be the approximate.
Very quick question. Isn't the mixing of fuel and oxidizer more important than displacement?
No, so injecting the right amount of fuel by atomizing is also an important factor. And the piezoelectric actuators which are currently in market have low material coefficients, which limits their strains. And that is the importance.
Very, very, very good. Thank you very much.
Thank you.